What's the question?
No, about the same question that.
No. I'm asking the person who asked the question. What is the question about?
Hello, ma'am. Can you hear me?
Yes.
Ma'am, the question is about a statement. If two different quadratic equations have the same discriminant, then roots of both equation can be same.
So two quadratic equations with same discriminant. And it's about whether roots can be same.
Then the roots of both equation can be the same.
Yeah, they can be same. They're not always same, but they can be same. If it says can be same, then it should be correct. Is that okay?
But ma'am, they are taking class like this, it can't be same, never. Because if only the case is for the equivalent quadratic equation, like I gave you the example, for that case only it will be same, but it is the same equation. You subtract, multiply or divide something.
You have this, right? And then you have 2a here. So you're saying that if your discriminant is same, let's say b square minus 4ac by 2a. This is a different thing, and then you have here minus b by 2a. So let's take, for the discriminant thing, you need b square minus 4a. Okay. It involves two things here, right? Minus b and a. It involves b and a both. And your b and a, let's say this thing turns out to be the same for both equations, this entire thing, right? B square minus 4ac. Let's denote one by capital and the other one by small. And then we have b square minus 4ac by 2a. So this will be, these two things are same. And it's automatically, it says that the discriminants are same. That means these two things are same. So your 1 by 2a and 1 by 2a has to be same. So a and a has to be same if you're taking these two things. Okay. Let's drop this 2 and let's take this here. Minus b by 2a plus minus square root of b square minus 4ac by 2a. Now, this says if your discriminant is same, you will have, let's divide both sides by this discriminant. You will have minus b. Okay, you'll be left with discriminant anyway.
I have a suggestion. Just take a simple case of when b square minus 4ac becomes 0. So say you take x minus 2 the whole square and x minus 1 the whole square, because you have repeated roots. The discriminant is going to be 0. That means the discriminants are equal, but the roots need not be equal.
Yeah, the roots are not equal, but we need a case where there are two different quadratic equations. What you've done is you've taken two different quadratic equations with same discriminant where roots are not equal. But the question is, can they ever be same? Is there a case where they can be same? For that, you either need to prove that they never can be same, or you need to have an example where they're same.
Ma'am, is this doubt clearing session or a revision session?
This is a revision. This is a revision session. We'll take this doubt towards the end because it's going to take time, and we're not left with much. We have a lot to revise. So let's revise things first, and then we'll take up this question. Is that okay?
Okay.
Okay. So,
excuse me, ma'am.
Yes.
Ma'am, are we going to revise all the 4 weeks, ma'am?
Yes.
Ma'am, like mostly we are having doubt in 3rd and 4th week, ma'am, not in.
Ma'am, excuse me.
You had doubt. Just 1 second. You had sessions for week 3 and 4, right?
Yes, ma'am. My week 1 and 2 is almost clear, ma'am.
Then why didn't you bring up your doubts in those sessions?
Like doubt, ma'am, but I want to.
Your voice is not clear. Yeah. this session was supposed to be, because we have a lot to revise from week 1 to 4. You might have everything clear from week 1 to 2, but other people might have some doubts, might have some problems from there as well, right?
Yes, ma'am.
Hello, ma'am.
Okay, ma'am.
Ma'am, can you reverse the order?
No, we are going from 1 to 4. Okay, so just give me a minute. From week 1 to 4, that way only you will be able to connect things. Otherwise, if we start from everything will get messy. That's why we'll start from week 1 and then we'll go. We'll quickly go through there'll be a very quick recap of weeks. We're not going through the entire summary of each week. So first is
Set.
So first is a set, and we're not discussing the definitions and all of sets. What is a set? What is a subset? And then all of that. So we're starting directly from Cartesian products. Cartesian products are basically, if you have two sets A and B, then the Cartesian product of the two sets A, B is where it's a tuple where first element in this tuple, first element here, is coming from A, and the second one is coming from B.
Ma'am, a little slow.
This is from A. What?
A little slow, I said.
Okay. So this is the Cartesian product, is where you take the cross product. This is cross product or Cartesian product, whatever, of two sets. Is basically you have a set A, a set B. Let's say your A is this, A1, A2, and so on till AN. Then you have B, where B is B1, B2, and so on till Bm. Or because you want to have a Cartesian product. So if this is it, that this means that it's the collection of all the elements. Your A cross B is the collection of all the elements of A, B type, A comma B, where your A is coming small a. This first element is coming from this A set, and the second element of this tuple is coming from the B set. This is it. This is your Cartesian product. So the total number of elements here would be, here you have n number of choices, here you have m number of choices. So the total number of elements will be n into n. Okay. Then coming to relations. So relations are always defined on a set first things first. So relations are defined on a set, and let's call that set A. Let's say A. So that means your relation is the subset of the Cartesian product A cross A. So if this is a relation and you're defining a relation on A, that means R, that relation is a subset of A cross A. So let's say you have A, your set is 1, 2. Then A cross A is 1, 1, 1, 2, and 2, 1, and 2, 2, right? That's it. So this is your A cross A. Then every relation on A is going to be a subset of this set, this entire A cross A. That's what's first thing. And what is a relation? It's basically take one element from A and the other element from A as well. That's the idea of relation. Is that okay? So let's say you have to define a relation on this set. Then your relation could be 1, 1, 2, 1. This is a relation on set A. This is it. Then we have types of relations. So the first relation that we have is reflexive. These are the basic ones that you need to know. So reflexive is basically when you have, let's say, R defined on A, where A is the set, this is the relation. So this R would be called a reflexive relation if for all A belonging to the set A comma A belongs to R. So that means, let's say your set is 1, 2, 3, and you have to define a relation, a reflexive relation on this, and you have to define a relation which is reflexive. Then what you need to do is you'll have to define it in a manner such that you have a 1 here, so we need a 1, 1 here. You have a 2 here,
2,
so we need a 2, 2 here, and then 3, so you need a 3, 3 here. That's your reflexive relation.
Excuse me, ma'am.
Yes.
Can only 1, 1 and 2, 2 of set will be reflexive?
No, if you've been given this set and then you're saying this relation R is equals to 1, 1 and 2, 2, this is not a reflexive relation on this one, on this set. But if you change your set and let's say you're saying I'm taking the set to be 1, 2, then it's reflexive here. Is that okay? Okay. So then the other one is symmetric. So symmetric is, we say R is symmetric on A when, or you're saying a relation is defined on set A, and then how you have to check is every element from the set should have. So if one is there, if A is in the set, this is the symbol for all. That means for every element in A, your A comma A pair should be in your relation. That's when it's called reflexive. For symmetric, you need for all AB belonging to the relation, you will need B comma A in the relation. That means if you have a pair, or if this confuses you, you should write if AB belongs to your relation, then BA should be there in the relation. That means if this is the same set, if I'm taking the same set 1, 2, 3, then my A, and let's say I have to define a symmetric relation this time. So if I'm taking 1, 3, then I need to make sure that 3, 1 is also there. Only if 1, 3 is there, then is when you have to make sure that 3, 1 is there. So if this is the hypothesis, if this is satisfied, if A, B is in R, then B, A must be in R. That's your symmetric relation. Is that okay? And then third, you have transitive. So for transitive, you need.
Ma'am, that's true for only one pair, right? Even for one pair.
Yeah, this one is a symmetric relation on A. If you have more than that, let's say if you have 1, 2 here, you need it to be true for every pair. This means whenever A, B, and A, B is an arbitrary element in relation, right? So whenever you have a pair that looks like A, B in your relation, then B, A should be in R. Like in this one, 1, 3 is in the relation. So 3, 1 should be there. 1, 2 is there. So 2, 1 should be there. If it's not there, then this is not symmetric.
Excuse me, ma'am.
Yes.
Ma'am, then what's the difference between identity relation and reflexive relation?
Identity relation is basically, when you have an identity relation, it's basically, okay. Identity on A means, or identity relation on A means, here I'll write it so you can spot the difference. Let's say you have to define R on A. So this will be an identity relation if this only should have, let's say A is 1, 2, 3. To make things simpler, let's take A to be 1, 2, 3. Then your identity relation is just this 1, 1, 2, 2, 3, 3. Now, is an identity relation a reflexive relation? Yes. Is every reflexive relation an identity relation? No. This is an identity relation. Now look at this relation 1, 1, 2, 2, 3, 3, and 3, 2. Now this is a reflexive relation, but it's not an identity relation. That's the difference. This is reflexive. This is identity and reflexive both. Is that okay?
Okay, ma'am, clear.
Okay. Moving on. We were on transitive relation. So
excuse me, ma'am.
Yes.
So basically, it means that there can be extra pairs in a reflexive relation, but there cannot be. Okay.
Okay. So now you have A, B, B, C belonging to your relation, let's say. Then you need, so whenever, I should write whenever. So whenever you have two tuples or two pairs, AB and BC belonging to R, then this should imply this, when I've written whenever, so you know the importance that whenever two pairs are there with the second element and first element common, so if the second element of this and first element of this are common, then AC should be in R whenever this thing is happening. If 1, 2 is there, 2, 1 is there, then 1, 1 should be in the relation. If 1, 2 is there, 2, 4 is there, then 1, 4 should be in the relation. Okay. For every element. So let's say you have the same set A and you're defining a relation here. Then you'll have, let's say you have 1, 3, then 3, 2. Then to make this transitive, you will need 1, 2 pair here, right? And let's say you have, so this you can consider this is a transitive relation because the second element of this, first element of this are common. So you need 1, 2 in the list. And the second element of this is not common with the first element, any other pair. So you don't need to check anything. Second element of this is not common with the first element of any of these. So you don't have to check anything. Is that okay? Yeah.
Ma'am, there is a question about anti-symmetric in EPA. Can you explain a little bit?
Yeah, just tell me which question it is.
Can you explain the anti-symmetric relationship?
Ma'am, one general question.
Yeah. Yes.
I am telling that for in term, the graded assignment of 7 week out of the 12 week will be considered, right?
What? Any
For,
doubts? Yeah. Are there doubts regarding these things, GA and all? What's your doubt again?
Yeah, GA.
It's regarding GA, right?
Yeah, not a question, but I'm asking about the eligibility.
Yeah, we'll discuss that later. And this is a revision session, and we have a lot of questions to do, a lot of theory to revise. So I need you guys to understand that we don't have a lot of time to discuss everything here, right? So if anything regarding the course and how things are calculated, how marks are calculated, we can take those questions up towards the end of the session, at the end of the session. Is that okay?
Yes, ma'am.
Ma'am, the anti-symmetric can.
So the anti-symmetric one, let's say you have R on A and you have AB belonging to A, such that your A, or let's say, so this one, okay, let me just write it more precisely. This one says that if your AB and BA, let's say if both of these relations are related, like if both of these pairs are in R, or equivalently you can say under R, A is related to B and B is related to A, then this should mean that A and B are same. So that's your anti-symmetric relation. That means the only time you'll have both of these same, okay. Let's say when you have a relation A, when you have AA in the relation, what does this mean? This means if you have, let's say, that's why it's called anti-symmetry. That means if you have AB and A and B are different, A not equals to B. In other words, or you can phrase this as if AB is in R such that A and B are not equal, this means BA should not be in R. Is that okay?
Yes.
So you can use
I
either
can't
definition.
understand it.
You don't understand this?
Ma'am, my way
Ma'am,
of
can
looking
you
at it is if
do it
AB belongs
example,
to R,
please?
if AB belongs to R and BA also belongs to R, and if A is equal to B, then it's an anti-symmetric relation, right, ma'am? That's all it is.
Yeah. These two things are essentially the same things, just put in different words. That's it. Because this
Ma'am, can
is
you give me example, please?
So, ma'am, what is the
okay.
difference between anti-symmetric relation and symmetric relation?
This is, you see the difference from here. What does symmetric relation says? It says if your AB is in the relation, then I want BA to be in the relation, right? This is what symmetric means. But anti-symmetric means, as the name suggests, it's not in favor of symmetry. So it says that if AB is in the relation, then BA should not be in the relation. That's what it says. This is anti-symmetric relationship. But there's
Okay,
a caveat here, which is if A is not equal, let's say if your A and B are equal, then your pair would be, this pair would become AA. And then I can't say that AA should not be in R. This is a contradiction, right? If I'm saying AA is in R and AA is not in R, this is a contradiction. That's why I mentioned here that A should not be equal to B. So this is because it's easier to learn, you see. Symmetric relation is AB. If AB is in the relation, BA should be in the relation. Anti-symmetric relation is if AB is in the relation, BA should not be in the relation provided A and B are not equal. That means when A and B are not equal, for every pair AB, BA should not be in the relation. Is that okay?
Got it.
Okay.
Yeah, ma'am.
Okay.
Ma'am, I have a
And
doubt.
yeah. Yes.
Ma'am, the odd and even function
Okay.
is not taught by the prof, but it is in the extra practice assignment of week 1. Can we find any question regarding this in the quiz one?
Odd and even functions, I don't think you will. Okay, you won't be given. I'll just tell what you know what odd and even functions are, right?
Yes, I know that, but
okay, there can be questions from there, but there's a possibility. There's a very little possibility that they won't give you the definition if it's not mentioned in the course itself. Then you're going to get the definition of what an odd function is and what an even function is if it's used in your question. But that doesn't. If it's not in your syllabus, that doesn't mean they cannot ask questions on that. You can be asked question on that, but you'll be given the definition if it's not explicitly given in your syllabus. Okay. Okay. So then
Hello,
we
ma'am.
have yes.
So can we say if a relation is not symmetric, we can say it is anti-symmetric?
Okay, let's say if you're saying if there is a relation, then can we say that there are only two possibilities? Either it is symmetric or it is anti-symmetric, right?
Yes, ma'am.
Is that what you're saying? So the answer is no. There could be a relation which is not symmetric and it's not anti-symmetric either. And how is that possible? Let's take a set. Let's take A is equals to 1, 2, 3. And our aim is to find the relation on this set such that it's not symmetric and it's not anti-symmetric. So let's take 1, 2 and 1, 3 here. Then for this to be anti-symmetric, for this to be symmetric, I need the reverse of each pair, right? So I'll need 2, 1 here. Let's keep 2, 1, but I'm not keeping 3, 1. So if you look at this relation, this is not a symmetric relation, right?
Yes, ma'am.
This is not a symmetric relation because 1, 3 is there, 3, 1 is not there. This is not an anti-symmetric relation either because 1, 2 is here. And this says if 1, 2 is here, then 2, 1 should not have been here, right? For this to be anti-symmetric. That means this relation is neither anti-symmetric nor symmetric. Is that okay?
Okay, ma'am.
Ma'am, please give the example of anti-symmetric relation.
Let's define one relation here. Let's say you have, this is an example of anti-symmetric. Just 1 second. Okay. This is not an example, right? We have taken this 2, 1 here. Let's take 1, 2 and 1, 3. Now this is a relation on this set, right? And this is anti-symmetric. Why? Because we have 1, 2, but we don't have 2, 1. We have 1, 3 and we don't have 3, 1, right?
Okay, ma'am.
And this is 1, 1. If I add 1, 1 to this set, it's still anti-symmetric. Is that okay?
Are you sure 1, 2, 1, 3 relation is anti-symmetric?
this is, I can instantly see that it passes through 3, 0 and 0, 3. But if you cannot see this, I hope you can at least see this form, slope, the intersect form, which should bring you here, that this is 0, 3, this is 3, 0. So your line looks like this, right? And then it's reflected about this axis. So that means this is, and then it's reflected like this, right? This is reflected off the x-axis. So that's this is the reflected ray, and this was the incident one, right? And you've been given the equation of this, which is x plus y is equals to 3. You have to find the equation of this. So look at it like this. This is a mirror, and then this line, which is x plus y is equals to 3, and this point is 3, 0, gets reflected here, and you have to find the equation of this line. So if I look at this thing, and this point was on the y-axis was 0, 3, right? Here on this line, right? This is 0. If you've studied the coordinate geometry well, you would understand this diagram. Distance between this point and this point is 3. This horizontal distance is 3. Similarly, this distance between this point and this point, the point, this one, this is also 3. So this, if you reflect it here, it's like taking the reflection of this. This is the mirror taking the reflection of this point here. So this in the reflection of this is going to lie. So if this is at distance 3, this is going to be at distance 3. So this is going to be, this coordinate is different. This is going to be 6, right? Because this is distance 3, horizontal distance 3, this is horizontal distance 3. So the total horizontal distance of this point from the y-axis is 6. That means your x coordinate is 6, right? And then what about the other coordinates? It's the y coordinate, which is the height. Right. And this height is the same as this height, and it's the same as this height. So it should be 3. So this is your point. That means you already have one point on this line, which is a reflection of this line. Then you found another point on this line, that's now 2 points, which means you can find the equation of this. You only have to find the equation of the line that passes through 3, 0 and 6, 3. X minus 3, and what's the slope? It's 3 minus 3. So it is this 1, right? So this is going to be y is equals to x minus 3, or you can say x minus y is equals to this one. Is this okay?
But if the equation, if the mirror equation, or if it is getting reflected not on the x-axis but along some other line, then it's more complicated. We can't. I don't know whether we can just use this method.
That's why you won't be given something like that.
Okay.
Okay. So you'll only be given, because it maintains the symmetry well. If this is distance 3, then this is also distance 3. That's why you're given this question.
Yes, I
If
use
this
the
is
more complicated way because I just use the angle of intersection with the normal of both these rays are same, and I use that method to actually calculate. It's more complicated than this, but that's a general method. This is specific.
Yeah, that's okay. Okay. So is this one clear to all? Can we move to the next question?
Yes, ma'am.
Okay.
Yes, no, is over.
This is about roots. So, and we have not done week 3, week 4. This is also about those things. Okay, which other questions are from this week? Can't see question from this week. Here, we have a question here from this week. So this is, let R be a relation defined on the set non-zero rational numbers. And so your set is Q. Your relation is a subset of Q cross Q. It's defined on the set Q. And the relation is AB will be in the relation if and only if the product of AB is 1, which means, now let's test if this is a reflexive relation or not. Let's say I have, so for reflexive, what you have to do is A belonging to Q cross Q, or you can say for all A belonging to rational numbers, this Q is the set of rational numbers. For all A belonging to set rational numbers, you want A to belong to this relation R, right? This R is the relation, Q is the set of rational numbers. So you want A to be in R. And when is AA in R? We know AB is in R if and only if the product is 1. So that means AA is in R if and only if A. So you'll have A is equals this mean? What did we want for this relation? Reflexive relation, why the others are not correct? Let's see. This is not correct because this means if you have AA in the relation, then that's only possible if you have, that means these type of elements in the relation are only these. That means only these are the points that are of the form AA that are related. And the other ones, 2, 2, 3, 3, they are not here, right? That's why this relation is not a reflexive relation. Not reflexive. So you just need one thing which disproves that this is not a reflexive relation. So you can 2, 2. 2 belongs to set of rational numbers, but 2 cross 2 square, 2 into 2 is not equals to 1. That's why it's not reflexive. Then coming to the second one, it's about symmetry. So let's say you have A, B.
It is symmetric,
in
ma'am.
R. And let's say this is given to you. For symmetry, we need B, A, R. Which means, and this means product of AB is 1. This implies product of BA. This one is 1. And we need BA to be 1. That is, BA is equals to 1, which is true, right? Here. Gotten BA is equals to 1 because AB was 1. That's why this pair BA is in the relation. So this means it's symmetric.
Ma'am, so if any relation is reflexive, it will be automatically tend to become symmetric as well.
No. Reflexive relation is, let's say you have R relation defined on set A. So reflexive relation means for every A belonging to A. So whenever I have an element of A, I want A, A to be in this relation, right?
Okay.
Now your A
There's
here
no
is
B.
Q.
There's no B in
Yeah, B here. And in symmetric ones too, you don't have a B and all that. It's just R on A where both A, B are coming from A, or you can say, because we don't need the sets here. It's just simply if AB is there, then BA should be there. We don't need the sets and all here. But on reflexive, we need to know the set on which a relation is defined, right? So this is incorrect. This was correct. Then coming to the transitive part, which is if AB is in R and BC is also in R, what does this mean? This is, let's say, given to you. Then, and this is what we want. For the relation to be transitive, we want AC to be in the relation, right? That means we want product of A and C equals to 1.
Yes. From the first two, we get A is equal to C.
Yeah. So from here we get AB is equals to 1. And from here we get BC is equals to 1. Now if you equate, because both of them are equal to 1, so you equate them to each other to get AB is equals to BC. And this will give you this will give you A is equals to C. Now what did we want? We wanted AC is equals to 1. What have we got? A is equals to C. Now let's take a case where A is equals to C, but AC is not equals to 1. Can we find one such case? If that happens, that means the relation is not transitive, right?
Yes, ma'am.
So let's take 2 and 2. Again, let's take A is equals to 2 and C is equals to 2 as well. Now this means if I take in this pair, if I take A is equals to 2, C is equals to 2, and B is equals to whatever, you can take B to be whatever you want. Then if I want AC to be in R, I want the product to be 1, but the product is 4, right?
Yes.
But for A is equals to C is equals to 2, AC is equals to 4, which is not equals to 1. That's why this is not transitive.
Yes, only symmetric.
Yeah, only symmetric. And because it does not satisfy these two, that's why it's not equivalence relation either.
Ma'am, your voice is breaking.
This is also incorrect. And let's see if we have. Okay. Is it clear now? Is it still breaking?
Yeah, no. It's okay.
Okay.
Not now.
So this is the next question. You have to check all the reflexive, symmetric, transitive things for this one. Let's do this one quickly. Do we have others? Yeah, got a lot of questions on this too. This one is on functions again. And then we have to do this one too. Yeah. So let's do this one first. You have been given you don't have to read this entire thing. We know that there is a set given to us, which is is identified by a pair of natural numbers. That means your A, the relation you define R on A, right? So your A is given to be natural numbers here. So that's all we needed. And then the relation is this. AB is related to CD. Now, initially, when we used to have things, we used to have, okay, A is not N then, right? It's N cross N. So initially, when we used to have things, we used to have A as A, B, C, D, and then we'll define a relation on it. And sorry, your relation would look like this. The elements in your relation would look like this, right? A, B, or these type of tuples, right? A and B coming from whatever sets. So now what's happening is your A is of this form. A1, B1, or let's say AI, let's take A1, B1 only. A1, B1, A2, B2. So your A set is of this form this time. So your relation would be of what form then? If I have to define a relation on this set, then what should it look like?
Ma'am, it is reflexive.
No, that's fine.
Ma'am, your voice is breaking.
Okay, is it clear now? Is my
Yes,
voice
ma'am.
still breaking? Okay. So if you have to define a relation on this set, A set, let's say A set.
This is recursive function.
Then your relation, yeah, okay. Your relation should look like this, right? A1, B1, A2, B2. This is what the elements in your relation would look like, and so on, right? Any relation defined on this set that's given to you should look like this. First thing is this to notice. Then second thing is, let's see if this is reflexive or not. For this to be reflexive, you want AB. That means AB, comma, CD. This pair is in the relation if this given condition holds, right? So let's check if this is reflexive or not. For reflexive, you need AB and AB belonging to R for all AB belonging to N cross N, right? So this will be, and what's the condition? We want this. And this is true only when AB, what was it? The product of first and last and sum of the middle ones. And then product of the
No,
middle
it is
ones
not
and sum of
symmetric.
last. Okay. AB and BA, this will give you, this should be equal to product of the first and last and sum of these, B plus A, and product of the middle ones and sum of the first and last. So these two, because these two are equal, AB, B plus A, and BA, A plus B, because these two expressions are equal, that means AB, comma AB is in R. That means R is reflexive.
Yes.
If anyone has a doubt in what we're discussing and what we've discussed so far, you can unmute yourself and ask. Discuss things in detail. Otherwise, I'll assume that you've understood and we'll go.
Relation is symmetric also.
Okay, let's check for symmetry. For symmetry, you want if AB
No, ma'am, not symmetric, I think.
and CD
Symmetric.
are in R, then this should imply that CD and AB are also in R, right? That's the condition that you have to check. Now, when do we say that these two are in R? It's when the product of the last, AD, sum of the middles, and then this BC and A plus D. If these two are equal, right? So this is given to you, right? This is given. This entire thing is given. This is what you have to show.
Ma'am, in place of A, we have to place B, and in place of B, we have to place A, and reverse
Okay.
also in C and D.
Just 1 second. This is given to you. And what do you have to show? So our to show is product of these two, BC, and the sum of the middle two, A plus D, should be equal to product of these two, DA, and sum of the outside ones, which is C plus D. This is what you have to show in order to prove this. And this is what is given to you, right? This is given, so you can deduct this from this one. And this is what you have to prove. That means you have to prove this. And these two are essentially the same thing. So what's given to you is the same as what you have to show. A plus D, B plus C, and AD. Right?
Yes, ma'am. Actually, proving transitive is the most difficult one.
Okay. So this implies this is symmetric. So I'd like to encourage the people who have any doubt to ask them here. Even if it's a very little doubt, that's fine. Otherwise, we'll keep going on like this. So this is
move to
transitive.
transitive.
For transitive, let's say you have AB, CD in the relation, and then you have CD and EF in the relation. This is given to you. If this is given to you, you have to show, and your to show is this. To show means you have to prove this thing. Using this information, you have to prove this. Just 1 second. Okay, you have to prove that AB and EF, this one and this one, when paired together, should be in R, right? This is what you have to show. So let's write the first one in terms of its definition. It will be A, B plus C equals to BC, A plus T. And this one will be CF, D plus E equals DE, C plus F, right? So this is given to you, and you have to show. To show is AF, B plus E is the same as DE, A plus F, right? Where is this is BEA? Do we have BEA anywhere? No, we don't. We don't have direct things here, right? Okay, so this will be ADB plus ADC is equals to BCA plus BCB, and this is CFD plus CFE is equals to DEC and DEF, and this one's AFB plus AFE equals DEA plus DEF. FEA. Okay.
Yeah, this involves a lot of algebraic manipulation. You'll have to take common terms and do it.
Yeah,
right?
I think we should. I was thinking of clubbing these two, but then and these two.
But it's
Then
transitive.
we have F. Okay, F. Let's do it here then. Let's see. BEA, and you can club these two too. Let's see which clubbing helps us. If you club these two, then we'll have AE as common and F plus B here. Do we have something like that here? AE? No. Okay. If we'll take this one and this one, we'll have EF common and A plus B here.
Won't it be A minus B?
Which one? Okay, these, that's on other side, right? We have 6 variables, right? So let's do. Let's write A in terms of the other ones, B, C, and D. Let's try to eliminate things from here. Let's write A, because I don't think this will help. Let's take A in terms of this. So it will be BC, A plus D by D here. And then from C, we're taking A, D, B, C. Okay. We only need A, F, D, and E in the expression, right? So we need A, B, F, and E. These are needed in the expression, and we have to eliminate everything else. So this will be ADB plus ADC. So if we have to eliminate B, we'll have to take this D here, and it will be ADB minus DCD. So we can take D common from here. You will be left with AB minus BC. We also have to eliminate C. Okay. So this will be D is equals to BCA plus ADC minus ADC, right? This will be minus ADC. This will give you D common, no, C common. And this will be BA minus AD. Okay. So you will have D by C equal to this thing by AB minus BC. And then similarly, we can do things here, right? So this will be CF. Let's try to do the same here. Let's try to get out D and C from this entire thing. So D, this is CFD minus CF plus CFE. And this will be DEC and DEF. Let's take C common, or because we're trying to, so be CFD and you take CFD from here. Do we have, okay, we've not gotten rid of D from here. D is still here, C is still, okay. This is of no use then. We need to get A and D. Sorry,
I remember
D
that
and
we have to convert this into a reciprocal kind of a thing, and otherwise it will be very complicated. Like
I was
you have to,
thinking of let's have D and C outside of this equation. Can we do that?
yeah. So I remember I just looked at my notes because it was a little complicated. So you will get it as 1 by B plus 1 by C is equal to 1 by A plus 1 by D if you rearrange the first equation. So similarly, we have to rearrange the second equation, and then we'll have to equate both. It's pretty complicated. Finally, you'll get it.
Okay. So
I don't know. Maybe I can send an email or take some photo and send it.
AB plus A.
You can put
Can
in
we
the chat
just not
section
isolate B,
by
D and
screenshot.
yeah, just put the screenshot there because
But the chat is just overloaded with spam. It's difficult. I've actually disabled the chat itself.
There is no spam
Let's-
because only 47 people left.
okay, this one is you can try this one because this is going, I have a feeling that this is going to take time
Yes, ma'am.
for us to rearrange the terms at all. So we should just move to the next question, I think.
Better, ma'am, because it's just algebraic manipulation. That's
Yeah. Okay, the next one is this one. This one. This one is the range of the function. You have to find the range of this function and defined by this thing. So the range should be you have -1 and then something to the power of this. By the way, if because we have a we have a -1 here, right? That's going to change things. So that's why, because you have a -1 here, that's why they're giving you that this x has to belong to natural numbers. So if your x belongs to natural numbers, and natural numbers includes 0, right? So if you take 0 here, you'll get -1 power, and -1 power is the reciprocal. Okay, that's fine. So this will be, if you start from 1 here or 0 here, you'll have power -1, then you will have -1 to the power 0, then -1 to the power 1, then -1 to the power 2, and which is basically just -1, 1, -1, 1. That means the values that you get for this function, if this is your function, then because the domain is only natural numbers, that's why the values you can get is only these two values, -1 and 1. And they'll keep repeating alternatively. So that means
Yes.
the domain should
Option
be,
B.
the range should be this one, -1 and 1. Okay. Then coming to this one.
ma'am, if those are the intervals, just
Ma'am, by curly bracket.
yeah, it has with a square bracket one.
It has curly brackets, right?
Yeah, but -1
We have option A
included.
to
Option
square
A.
brackets.
The option A is this is the range, right? This is like from -1 to 1.
Okay, got it. Yeah, 0 is included in that.
This means every number between -1 and 1 is included in this set. That's why it's incorrect. Do we have a doubt in these two options? Does anyone have a doubt in these two options?
Curly bracket one.
Yes, ma'am.
Um, Oh,
Yeah.
I
The
don't.
curly brackets include indicates just two values, -1 and 1. That's it, right? That's how we have to take it, ma'am. The curly bracket.
Yeah. This one means when you have a set, this is the notation for set, right?
Set,
So if you
right.
have A, B, C, this means it only has three elements, A, B, and C. And same has happened here. So if you see something like this, -1 and 1, it means this is a set which has only two values, -1 and 1. And when you see something like this, A, B, this means this is also a set, but it's a set of all the values starting from A till B, and A and B both are included. Yeah.
Yes,
So it's
understood.
like an interval.
Yes, ma'am,
That's the
understood.
difference between these two options. Okay. Then coming to this one. This is the last question, I guess. From week 1 and 2. So the question is, the triangle has two vertices, two of its vertices at 0, 1 and 2, 2 in the Cartesian plane. Its third vertex is, so 0, 1 is, if you will have this, 0, 1 is here, right? And 2, 2 would be somewhat here. Let's say this is 2, 2. And its third vertex lies on the x-axis. So it's somewhat, it could be here, it could be here, it could be here, right? This entire thing is x-axis. Let's take it arbitrarily here. Let's call that point x, 0, right? Every point on x-axis looks like this. So the point is x, 0. If the area of the triangle is 2 square units, that means the area of this triangle is 2 unit squared. If this is it, then the sum of the possible edges of the third vertex is, then you have to find the sum of, okay, why have they said is there could be more than one point possible, such that the area of this triangle is, it's possible that the area of this triangle is 2 units, and then the
Ma'am,
area of
option
this
A.
triangle.
Ma'am,
Okay.
x equal to -4.
Okay. Then the area of this triangle is